Problem number 14 on page 215, the details that were given are in this red box. We're asked in part A to find the velocity when t equals 0. So we have to find the velocity first, and that's the derivative of the position. And that's negative 32t plus 96. And when we find the velocity at t equals 0, we just replace t with 0 in the velocity equation, and we get 96 feet per second. Okay, so that's the first part of that's just part A. Okay, so let me put an A there. Okay, that's A. And then B is asking for us to find the maximum height and when it occurs. So maximum height, we know that when an object is shot up into the air, let's say, and it comes back down, we know that on the way up, that's what happens on the way up and then on the way down. On the way up, we know that the velocity is positive because velocity gives us not only speed but also direction. So then on the way down, that would be where the velocity is negative. Okay, well then that only leaves at the very top when the velocity is actually equal to 0. That's when the particle stops momentarily and then comes back down. So if we want to solve the equation velocity equaling 0, we say, all right, velocity equals 0 when negative 32t plus 96 is equal to 0. When we add 32t to both sides and divide by 32, we get t is equal to 96 divided by 32, which is 3. So at the t equal 3 second mark, let's see, what does it ask? Find its maximum height. So we don't yet know what that maximum height is, but we do know when it happened. So we do know that at the t equal 3 second mark, we have a maximum height. Well, and then so how do we find how high the object is at that time? Well, if we want to find the position, that's what we're being asked. We're being asked to find the position when the velocity is equal to 0, and the position depends on time. So let's do a little calculation over here. At the time of 3, the position would be s of 3. And so s of 3 is negative 16 times 3 squared plus 96 times 3 plus 112. And so we have negative 16 times 9, that's negative 144, plus 96 times 3, that's 288. Plus 112, 400 minus 144 would be 256, and that would be what? 256 what? That's 256 feet. So our answer to the second part of, or I guess the first part of part B would be 256 feet, and so let's write that over here. Max height would be 256 feet. All right, at the time t equals 3. All right, and then there's one more part, and that one more part would be the velocity when s is equal to 0. Okay. Well, when s is equal to 0, it means that the position is equal to 0, and we have to know what time that is. And so this is a good time to have our calculators that have that quadratic formula program. And so s is equal to 0. I'll write that down here. When, I don't like the red, s is equal to 0 when negative 16 t squared plus 96t plus 112 is equal to 0. Well, I guess it's not so bad. We can go ahead and factor out a negative 16 from all three terms, and we get t minus 7 times t plus 1 is equal to 0, and that means that when t is equal to 7, this particle is, what is it, a particle? What does it say? I have an object. Okay. The object at time 0 is 112, but at time t equals 7, the particle is on the ground because s is equal to 0. Position is equal to 0 when t equals 7. But that's not what we were trying to find, is it? We wanted to find the velocity at that time or at that position, but the velocity doesn't depend on position. The velocity depends on time. And so we just replace t with 7 in the equation for the velocity. And the velocity is negative 32t plus 96. So negative 32 times 7 plus 96. Okay, and let's make a little separation here. And 7 times 32, 7 times 2 is 14. Carry the 1, and we have 224, so negative 224 plus 96. So that's negative 220 plus 100, so that's negative 120. Negative 120, that would be the velocity. Can I get that right? Negative 120. That doesn't seem right. 224 minus 96. And we have 14. 4 minus 6 is 8. And we have 21 minus is 128. I knew that didn't seem right. So we have 128. Negative 128 would be the velocity at that time. Well, why is it negative? Well, it's because it's coming down. And that would be feet per second. Feet per second. Okay? So negative 128 feet per second. And that is it for that problem. And let's take a look at number, whatever we have next. For problem number 28, we're asked to find two things. What value of a makes this function have a local minimum at x equals 2. So let's do that first. First of all, we need to find our derivative. Our derivative of the first term is 2x. And the derivative of the second term, again, I like to make sure that I get to use the power rule. I don't like to use the quotient rule. Okay, so I'm going to rewrite this f of x as x squared plus a times x to the negative 1. That helps me see a little bit better what my derivative would be. So that derivative of the second term then would be minus a x to the negative 2, which would be 2x minus a over x squared. And anytime we want to figure out where the derivative is equal to 0 or does not exist, we should get the f prime equaling just one fraction. And so if I get the first term, if I create the first term that has a common denominator, the common denominator being x squared, I know that I'm going to multiply top and bottom by x squared, and so let's do that there. And then let's rewrite this as 2x cubed minus a all over x squared. So that's our f prime. And again, we don't know yet what a is. That's what we're trying to figure out. And 2x cubed minus a, or f prime equals 0, when 2x cubed, when the numerator of the fraction is equal to 0. Okay, and again, we don't know what a is, but let's go ahead and do this. Let's remember that this function has to have a minimum, a local min, when x is equal to 2. So when x is equal to 2, we have 2x cubed minus a equals 0. Let's replace x with 2. So we get 2 times 2 cubed minus a equals 0. So we get 2 times 8 is 16. 16 minus a equals 0 when a is equal to 16. Okay? And when a is equal to 16, we could calculate the derivatives. Let's make sure f prime test to the left of 2. So if between 0 and 2, let's pick a 1. Okay, so if we pick 1, f prime, which is this guy right here, now we're going to replace a with 16. We have 2 minus 16, that's negative over a positive, so we have negative. And then once x gets past 2, we can see that, let's say 5. 5 cubed is 125. The numerator would be positive. The denominator would be positive as well. So we would have a f prime would be positive there. So that indeed confirms the fact that we've got the correct value for a. That would cause the function f to have a local minimum at x equals 2. Well, the second part of this, though, is to figure out when what would a be. Forget about part a now. What would the value of a be to then have a point of inflection at x equals 1? Well, let's first of all, when we talk about points of inflection, we need to figure out what the second derivative is. Okay, so the second derivative would be equal to, let's see, which part of this first derivative am I going to look at? I'm going to look at this one right here. Here I'm going to use this first derivative to find my second derivative, and the second derivative then would be equal to 2. Derivative of 2x is 2, and then plus 2a multiplied by x to the negative 3. Okay, so f double prime of x is equal to 2 plus 2a over x cubed. We need a common denominator, so we're going to multiply top and bottom of this first term by x cubed, and that gives us a nice concise way of expressing our f double prime, and that would be 2x cubed plus 2a, and that's all over x cubed. Keep in mind we need a point of inflection at x equals 1. Okay, so that means we let x equal 1, and I keep drawing that a little bit too close. Let me draw it over here. We need a point of inflection for the f double prime test at x equals 1, and therefore at x equals 1 the function is continuous, the second derivative is continuous, but what we need though is for the second derivative to equal 0 for us to have a point of inflection, and so we're going to replace x with 1, f double prime of 1 must equal 0, but let's put the 1 in, cubed plus 2 times a all over 1 cubed. Okay, that makes our numerator 2 plus 2a, and that 2 plus 2a must be equal to 0 for us to have a point of inflection, and that gives us 2a equaling negative 2, and a is equal to negative 1. So there's our value for a. That would make our second derivative equal to 0 at x equals 1. Okay, so we have both of our answers for problem number 28. That's a really good problem to make sure you know how to do prior to coming into the test, so you might want to make a note of that, because I remember there being a problem similar to that on the test, so keep that in mind. So our last problem from the homework after the notes is problem number 38, and the problem 38 is just asking, is the function f of x ever negative? In other words, does this function's graph ever fall below the x-axis? Well, first of all, we already know that the function's graph looks like that. It's a parabola that opens up. And so really all we have to do is find the minimum value, and if the minimum value is greater than 0, then no, the function would never be negative, and that's the explanation. So the way we find that is we just find the vertex even. We don't even need calculus for this one, but the calculus actually makes it easier. F prime is equal to 2x minus 1. F prime equals 0 when 2x minus 1 is equal to 0, or when x is equal to 1/2. Okay, so when x is equal to 1/2, if the y-coordinate of the vertex is above the x-axis, which it looks like it's going to be, then we have a parabola that opens up, and then the answer again would be no, that this function never is negative. It's never negative. All right, well, how are we going to figure out where that y value is? Well, if we want to know the y, we have to plug in the x. Okay, so f of 1/2 is 1/2 squared, and then we have minus 1/2 plus 1. Okay, so 1/2 squared is 1/4. 1/4 minus 1/2. Well, that number is going to be negative 1/2. Sorry, 1/4. Negative 1/4. 1/4 minus 2/4. Negative 1/4 plus 1. Either way, you're going to get a value that's greater than 0, so the answer is no, and for the reasons that I just described. I'm not going to write them out. I already talked about them, and that's it. See you in class. Oh, don't forget about those other problems, those multiple choice problems that you guys need to do, and then input your answers to those on the Google form this time. If you didn't do that last time, then you need to do it this time, and it helps me so I can figure out which problems you guys understand and which you don't. So we'll see you in class.